Welcome to this crash course on Docker. I am Rangarao Karanam. I have more than 20 years of application development experience with a variety of languages like Java, Python, JavaScript, and a variety of frameworks like REST API frameworks like Spring Boot, front-end frameworks like Angular, React, and Vue. I'm also an AWS certified solution architect. I've been using Docker to containerize microservices for a few years now. At In 28 Minutes, we ask ourselves one question every day. How do we create amazing course experiences? The success we had on a wide variety of platforms, including Udemy, with more than 300,000 learners, is a result of this pursuit of excellence. We believe that learning Docker is one of the most important skills for Java developers. In this awesome course, we'll help you get started with Docker by learning all the important basics of Docker. You will learn all the important commands as well as you will learn the important concepts around Docker, containers, images, repositories, registries, and a wide variety of other stuff. We'll create Docker images for a variety of Spring Boot projects, for web applications, full stack applications, for REST API. We'll also create Docker images and run containers for microservices as well. We have a couple of microservices called the currency conversion service and the currency exchange service. Along with it, we'll run containers for Eureka and Zool. One of the important takeaways of the course is your learning on Docker Compose. You will learn how to use Docker Compose to manage your containers. We will use Docker Compose with full stack applications and microservices. One of the biggest advantages with Docker is the fact that you don't really need to install software on your local machine anymore. You will learn how to use Docker Hub effectively, and we will use images of MySQL, Zipkin, RabbitMQ from Docker Hub and create containers for them. We expect you to know the basics of Java programming, and we expect you to have some experience with Spring and Spring Boot. Some knowledge of JavaScript and React would be useful when we are containerizing the full stack application. We will help you to install all the tools that you'd need for this specific course. The complete source code, including the step-by-step details, are available on the GitHub repository of this course. What are you waiting for? Let's have some fun containerizing a lot of Spring Boot applications and learning a lot about Docker. We had a lot of fun creating this course, and we are sure you will have a lot of fun too. If you want to learn more, go ahead and click the enroll button, or you can take a test drive using the free preview feature. Good luck, and I'll see you in the course. Welcome back. Let me congratulate you on making a great choice in enrolling for this course. In this step, let's get quickly started with understanding how you can make the best use of this course. The first thing I would recommend you to do is to bookmark the GitHub repository of this course. The GitHub repository of this course is github.com/in28minutes/Docker crash course. You can also find the link to the GitHub repository in the resources section of the video. The GitHub repository contains the source code for different projects that we will be containerizing during this specific course. We will start with containerizing a REST API. We will move on to a web application. After that, we will have the web application talk to MySQL. We'll containerize that, and later we would move to a full stack application, a React frontend, which is talking to a Spring Boot API. We'll also look at a number of microservices. The GitHub repository also contains a section called Getting Started. In this course, we assume that you have some knowledge of Spring, Spring Boot, JPA, Hibernate, and React. However, if you don't have that experience, you can quickly get started with those frameworks by watching these videos. You don't really need to start with watching all these videos right now. What we'll do is when we'll get to this specific section where we would use a specific framework, we will highlight the videos and articles which might be important for you. Now, let's move on to the installation guide section. The installation guide section contains installation instructions for different tools that we would be using during the course. The first sections of the course, we will be using Java, Eclipse, and Embedded Maven. So if you don't have Java or Eclipse installed, I would recommend you to follow the instructions in this specific video and install those tools. Any version of Java greater than Java 8 should be fine, and any of the latest versions of Eclipse should be awesome. When we get to the full stack application, you can install Node.js and Visual Studio Code. For now, you can skip that part. If you have any problems with the installations, you also have the troubleshooting instructions down here. Each of these projects contain a README file with more details about that specific project. We also have a few code backups at different stages of that specific section. Now, I guess I've bored you with a lot of these details. The most important thing is bookmark the GitHub repository. Make sure that you have Java 8 or a high version of Java installed. Make sure that you have the latest version of the Eclipse installed, and you are all set. I'll see you in the next step. Until then, bye-bye. Welcome back. In the first few steps of this course, what we would do is we will install Docker and execute a number of Docker commands. Docker makes the life of a developer as well as somebody from the operations team very easy. Installing Docker and executing a few Docker commands gives us a great perspective on what you can achieve with Docker. Once we get that perspective, we will talk about what is a virtual machine, how Docker is different from a virtual machine, and we will talk about the internal architecture of how Docker works. By the end of the first 30 minutes of the course, you should have a great 10,000 feet overview of how you can make use of Docker to solve your everyday problems. Now, let's get started with installing Docker in this specific step. A few years back, if I told my friends, let's come here, let's install Docker together, most of them would actually run away. Why? Because installing Docker was not easy. We were facing so many problems installing Docker that a number of developers don't even want to use Docker at all. However, things have changed for the better in the last few years. And today, installing Docker on most of the operating systems is really a cakewalk. It's just a click of few small buttons. How can you install Docker? Google for install Docker. The first link you should see is docs.docker.com install. Go in there, and over here you can find the instructions to install Docker on different operating systems. If you are on either Mac OS or Microsoft Windows, you can install Docker Desktop. Installing Docker Desktop is very easy. If you are on Mac, you can click the link install Docker Desktop on Mac. You can download the Docker Desktop for Mac from here by clicking the download from Docker Hub button. Once the download completes, all that you need to do is double click on the installer and drag the Docker icon into the applications folder. And after that, you can double click the docker.app from the applications folder to start up Docker. And once Docker starts up, you should see something like what I see in here. So this is the thing that you should be able to see. Installing it on Windows also should be very easy. All that you need to do is go back to the install page, click Microsoft Windows in here. You can download Docker Desktop for Windows, and the installing procedure is very simple. Just double click the downloaded exe, follow the instructions which are shown on the screen. It might ask you for a system password, so go ahead, enter it, and make sure that you follow through all the steps and install the Docker Desktop application. You can start Docker Desktop up by searching for Docker space desktop. Once you launch it up, you should see the same whale kind of a window in the status bar. The installation on Linux, however, is much more complex. So first you need to choose the distribution of Linux you are on, and based on it, you can follow the instructions which are provided on this specific page. After installing Docker, launch up your terminal or command prompt, and the thing you need to see is when you type in docker -- version, one of the latest versions of Docker. So I have a version 19.03.1. Make sure that you have a version which is at least 19 or greater. In this step, we quickly looked at the installation instructions for Docker. Make sure that you are able to execute this command, and I'll see you in the next step. Until then, bye. Welcome back. In this step, let's discuss a use case where Docker is most useful. You are working on a team. You are the star developer in the team. You're working on a challenging project with very tight deadlines. You'd want an application deployed to an environment quickly. You have a very good friend of yours working in the operations team, and you go to him and tell, okay, let's quickly deploy the application to the QA environment. And you tell him, okay, launch up terminal. He launches up terminal. On Windows, you might be using command prompt. So launch up either terminal or command prompt and type this along with me. He says, okay, let's check if Docker is installed. Docker -- version. Type it in. Okay, Docker is installed. So he says, okay, greater than 18, you're good. Now, let's run the application. Let's deploy the application. Run this. He says, Docker run in 28min / to-do -rest -api -h2 :1.0.0.release. He says, okay, this is the command, go ahead and run it. You press enter and you see that a lot of magic unfolds. Your friend from the operations team asks what's happening. You tell him, okay, wait, hold on, let's see what would happen. And you'd see that right now it's downloading something. It's pulling something. It's downloaded a new image, it says. And you are seeing now that a Spring Boot application is being launched up. And you'd see that in about 20 seconds, we are able to launch up a Spring Boot application. Your operations team friend is stunned. He tells you, hey, on this machine, Java is not installed. How is it running? Your friend in the operations team is actually working in a few older projects. He's used to the manual approach. He usually gets a document which says, okay, you need this hardware and you'd want to install Linux XYZ version, and on top of it install Java 8.5.10, install Tomcat 8.a.b, and then download this jar and then run it using this command. And what he tries to do typically is try to follow these instructions and install the application. And typically he makes a lot of mistakes. When I'm looking at a document and trying to type it down, a multiple set of instructions, there's a high chance that I make a mistake while deploying something. He's asking you now, how are we able to deploy this application that you have built so easily? You tell your friend, okay, that's the magic of Docker. Now, I know that's exactly the question in your mind as well. Let's look at what's happening behind the screens in the subsequent steps. I'll see you in the next step. Until then, bye-bye. Welcome back. In the previous step, we were able to quickly launch up an application just running a simple instruction. And your friend from the operations team is very, very curious. He's asking, where is this application downloaded from? You have typed in something in here, in 28min to-do REST API H2. What does this mean? What is this? And where is this coming in from? So let's answer some of the important questions in this specific step. Over here, when we run this command, what is happening is an image is downloaded from where? From something called hub.docker.com. Hub.docker.com is something called a Docker registry. A registry contains a lot of repositories, a lot of different versions of different applications. And because this is a public registry, anybody can access this. Typically, when you are working in an enterprise, we would be using private repositories so that our images can only be accessed by somebody who has the right credentials. If this is the registry where our application is, how do we locate our application? Right? So over here, you can type in -r and type in 28min, which is the name which we used in here. So in 28min / type in to-do -rest API H2. If you type this in and press enter, you would go to something called a repository. So hub.docker.com is a registry. It can contain multiple repositories, and inside that, in 28min / to-do REST API H2 is a repository storing all the versions of a specific application. So this is something that hosts a number of tags, and we specified 1.0.0.release as the version that we would want to use. Now, you might be wondering, what does this image contain? You'd see that this image is about 102 MB. This image actually contains all the things that your application needs to run. It contains the right software, for example, Java, a specific version of Java, Java 8 or Java 11, whichever version you'd want to use. It contains all the libraries your API needs. Your to-do REST API might need 15 libraries. It contains all of them. And it contains any other dependency that your application might need to be able to run. When we ran this command, this image was downloaded to our machine. So a local image was created. So from the registry, the image is downloaded to your machine. And once the image is downloaded, it is ran as an application in your machine. And this is what is called a container. Image is something static. So on the repository, image is a set of bytes. That's it. When it's downloaded, even then, the image is just a set of bytes. And when it's running, it's called a container. So image is a static version and container is a running version. And for the same image, you can have multiple containers running. Now, you might be wondering, hey Ranga, all this is great. I see that the Spring Boot application is running, but I would want to be able to access it. How can I do that? If you go further down, you'd see that it's running on port 5000. Let's go and try to run it. Localhost 5000. Actually, the URL for this is localhost 5000/hello world. Oops, error. What's happening? Why is there an error? Just press Ctrl C. This would terminate the running container. And let's do a clear and go up and try and run this command again. However, this time with a option. So we need to put an option called 5000 colon 5000. Why do we need this? I'll explain that. I'll press enter to start kicking off the process. What happens is by default, any container that you run is part of something called a bridge network in Docker. You can kind of think of it like an internal Docker network. Nobody will be able to access it unless you specifically expose it onto the host, onto the system where your container is running. So what we are doing in here is we are saying, I want to take the internal port, the container port 5000 and map it to a host port, to a port on the system where the container is running, which is 5000. So now I would be able to access the application on port 5000. You'd see that the application is launched up. Yep, it took about 20 seconds. I talked much more than that, I guess. And now you'd see that I'm able to access the URL. If you would also type in -bean, you'd see that there are a couple of other APIs which are exposed in here. I'm using Chrome, and inside Chrome I have a JSON viewer plugin, and that's the reason why it's appearing to be perfectly formatted. In this step, we got a quick overview of a few concepts related to Docker. Let's do a quick review of what we have discussed until now. When we execute the command, the image is downloaded from something called Docker Hub. Docker Hub is something called a Docker registry. A registry contains a number of repositories. When we are specifying the name in here, it's actually name of one of the repositories. And we are specifying which version, which tag of that repository to get. And once we specify that, we saw that the image was downloaded and run. The running version of the image is called a container. An image is a static version and the running dynamic version of it is called a container. And at the end, we also saw that we had to publish the container port to a host port to be able to access the application. I hope you are having an interesting time and there are a number of other Docker concepts you would want to learn. I'll see you in the next step. Until then, bye-bye. Welcome back. In this step, let's play around a little bit more with Docker images and Docker containers. What I'll do is I'll stop the running application. If I press Ctrl C, you would see that the container which is running would be killed. If I do a Ctrl C right now and try to run the application, oops, it's down. Now you'd want your application to be always running. You don't want it to be killed when you do Ctrl C. How can we do that? Let's do a clear down here. Let's go back to the instruction which we ran earlier. And over here, what I can do is add an option called -d. So -d stands for detached mode. So what we want to do is we would want to run the container in the background. We don't want to tie up the terminal to the life cycle of the container. So you'd want to detach it from that. Let's press enter. You'd get a container ID, and that's it. You don't see any of the logs. If you want to see the logs, you can say docker logs and the ID of the container. So I'll copy and paste this in. You can also type in a subset of the ID. You can also say C9B5 instead of the entire thing. So if I do docker logs, you can see some of the logs from that specific application. If you want to keep following the logs, the way you can do that is by saying another option. So docker logs -f. What does this do? This would start tailing the logs. It would start following the logs of that specific application. So if there is any new log coming in, I would be able to see it. Actually, none of the basic URLs are actually generating any of the logs. So what I'll do is I'll type in a complex URL which is exposed by this. So it's JPA-users in 28 minutes -todos. This will not really return any data, but it would actually execute a query, and you'd be able to see the query in here in the log. So what we are doing in here is tailing the logs. So we are looking at the logs of the application. You can press a Control-C to stop tailing the logs. Let's do a clear again, and we would want to see what are the containers which are running. I can do docker container ls. You can see that this particular container is running for about 3 minutes. You can see that a name was also assigned to this specific container. It's called blissful_wing. Don't ask me how the name was generated. And it's also assigned a ID. Actually, this shows only the first few letters of the ID. Earlier, when we ran the container, we were able to see the big string. That's actually the complete ID. Now, what I would want to do is launch up another container from the same image. Earlier, I said we can run multiple containers from the same image. What I can do is now I can run another version of the same application on port 5001. So we are doing docker run -p 5001 :5000 -d, and the same thing that we used earlier. Let's see what would happen. We are also running it in detached mode. So if I do a docker logs -f 38155, which is like the first 5 digits from here, you can follow the logs. We are now tailing the logs which are generating from the second container which we are launching up. Cool. The Tomcat has started on port 5000, it says, right? But how do we access it? The way we can access that is not by 5000. You would see that the way we would need to access it by using 5001. So if I do 5001, you would also get hello world back. So now we have 2 instances of the application running. One on 5000, the other one on 5001. Isn't it awesome? If I disconnect from the logs, so we just ran the command docker logs -f and we disconnected from it. And now I can say docker container ls. What does it show? It shows that there are 2 containers running, and these 2 containers are created from the same image. Now, I would want to see all the images which are present in my machine. Docker images. What does it bring? It shows that we have 1 image in here. Thing is, the Docker images only shows the images that are local to us, the images which have been pulled from the Docker registry. It's not completely showing all the images which are present inside the Docker registry, inside the Docker Hub. If you want to see any image down here, the first thing you need to do is to pull the image down. And once you pull the image down, you'd see that when you type in Docker images. The last command which we'd be looking at in this specific step is something called docker container ls. We used this earlier, right? Docker container ls lists all the running containers. I'll add an option -a. You can see that this shows all the containers irrespective of their status. You can see that these 2 containers are running up 3 minutes, up 7 minutes. However, these 2 containers have exited 8 minutes ago, exited 24 minutes ago. So docker container ls-a shows the running containers and the stopped containers. Now, before we end this step, let's stop the containers which are running. How do we stop the containers which are running? Docker container stop, and I can pass in the ID of the container. I'll enter 38155, which is the first 5 digits. So 38155, and I'll say docker container stop The other one which is running in here is C9B. So C9B5. Something unique at the start to identify the container is more than sufficient. You don't really need to enter the entire ID of the container. And now you'd see that none of the URLs would be working. And when I do a Docker container ls-a, you'd see that everything is now in a exited status. In this step, we talked a little bit more about images and containers, and we ran a few commands around images and containers. I'll see you in the next step. Until then, bye-bye. Welcome back. In this step, let's understand the architecture of Docker. The place we were running the commands in is called a Docker client. And when we type something in the Docker client, the command is sent out to something called a Docker daemon or a Docker engine for execution. So even the local installation of Docker uses a client server kind of architecture. So when we installed Docker Desktop, we were installing both the Docker client and the Docker daemon. The Docker daemon is responsible for managing the containers, it's responsible for managing the local images, and it is responsible for pulling something from the image registry if you need it, or pushing a locally created image to an image registry. The first two parts of that is very easy, right? Docker daemon is responsible for containers and local images. Earlier, we created a number of containers. If I do a Docker container ls-a, you'd see all the images that we have created and stopped. All these containers were created and stopped. All these containers were managed by the Docker daemon or the Docker engine, which is running on our local machine. The Docker daemon also manages the images which were downloaded. The Docker daemon knows that there is a local image for this specific repository and this specific tag. Now, if I would want to run a container based on the same image, let's see what would happen. So I'm removing the -d because I would want to see the logs right here. And let's continue to run it on port 5000. So Docker run -p 5000, and I'm using the same image name and the same tag 1.0.0 release. What would happen? You'd see that it's not really downloading the image again. It knows what containers and images are present in local, and it knows that this specific thing is already available, and it runs an existing thing. Now I'll stop this, Control C, and now I'll use a different tag of this. So instead of 1.0.0.release, I would do a different tag 0.0.1 -snapshot. So I'm typing in 0.0.1 -snapshot. We are running the command in Docker client. The Docker client sends it to the Docker daemon, and the Docker daemon now sees that the image is not available locally. It says, in this repository with this tag, the image is not available locally. So what it's doing, it's going to the registry and fetching that image down for us. So it will fetch down the image and then run it as a container. You can see that it's downloaded a new image for us. So the Docker daemon is responsible for managing our local stuff and also pulling something from the image repository if something is not available on our local. One of the additional capabilities that Docker daemon has is it can process instructions to create images as well. Until now in this course, we have been using images which are already created. But later in the course, we will be creating more than 10 different images for different kinds of applications, for REST API, full stack applications, and microservices. At that particular point in time, you would see that the Docker daemon would help us in creating those images and also pushing the images to the image registry so that somebody else can make use of them. In this quick step, we understood the different components which are installed when we install Docker Desktop on our machine. And we also understood the responsibilities of each of those components. We talked about Docker client, which is responsible for just sending the commands to the Docker daemon. We talked about the fact that the Docker daemon is responsible for managing our local containers, local images. It's responsible for pulling images from the image registry. It's responsible for creating images and also pushing out images to the image registry. I'll see you in the next step where we will talk a lot more about Docker. Until then, bye-bye. Welcome back. I'm sure you are itching to get your hands dirty and type in a lot of Docker commands. But one of the most important things is you should understand the big picture around why Docker is becoming famous. One of the things we saw was installing Docker on our local machine was very, very easy. So developers can use Docker easily. Now, what's happening these days is most of our environments are deployed on the cloud. The awesome thing about Docker is you can install Docker on cloud also very, very easily. Most of the cloud providers actually provide container-based services. So they provide services where you just need to tell, run this container, and it would automatically run on the cloud. Let's get a 10,000 feet overview of this phenomenon in this specific step. Before Docker, virtual machines were very, very popular. You have the hardware, you have a host operating system installed on top of the hardware, and we had something called the hypervisor to manage your virtual machines. So each of these was a virtual machine. So you have virtual machine 1, virtual machine 2, virtual machine 3. And each virtual machine had a guest OS, and on top of it, you have the software that you would want to install to run your application, and on top of it is your application. One of the major problems with these virtual machine architecture was typically these are heavyweight. We had two operating systems, host operating system and guest operating system. And that makes the whole thing a little heavy. And that's where Docker comes in. If you have some infrastructure and if you have some host operating system installed on top of it, all that you need to do is install the Docker engine for that specific operating system. And Docker would take care of managing these containers. The Docker image contains all that is needed to run a container. All the libraries, all the software are directly part of these containers. Because there is just one OS, the host OS, Docker is relatively lightweight. And therefore, it is very, very efficient. And that's why you'd see that all the cloud providers provide a number of services around Docker. Today, as we speak, it's very, very easy to deploy something related to Docker onto any of the cloud providers. Azure provides a service called Azure Container Service. AWS, Amazon Web Services, provides a service called Elastic Container Service. So the thing which we are understanding right now is the fact that using Docker on local is very easy and using Docker on the cloud is also very easy. And that's the reason why Docker is becoming really, really popular during the last few years. Okay, that's all theory done and dusted, and let's move into the next step where we would start getting our hands dirty and execute a number of Docker commands. I'll see you in the next step. Until then, bye. Welcome back. In this step, let's play around with images. Let's try different commands which are related to images with Docker. So if I type in Docker images, we have done this a number of times. Over here, we are seeing a couple of images, right? So we are seeing the repository and the tag. You can give 2 tags or 3 tags, multiple tags to a single image. So to the same image, I can give multiple tags. How can I do that? The command is docker tag. So I would want to tag this repository and this tag. So I would want, so this repository, this tag, I would want to add a new tag. I would want to use the same repository name and colon latest. I'm saying this is the latest version of this specific repository. What would happen if I say Docker images? Now you'd see that the image is shown twice. The same image is now being shown with 2 tags. So you can see the image ID is the same, 560, 560. However, it's now being shown with 2 different tags. Typically, a lot of projects, in addition to the release version, will use a specific tag called latest on the most recently released version of that specific project. However, it's very, very important to remember the fact that latest does not need to always point in to the latest release. It's just a tag. It's just another tag like 1.0.0.release. It's not an automated thing. It's a thing that you need to manually add. So if latest is actually pointing to this, then latest would actually download this version of your repository. The interesting thing with Docker is if you do a Docker run or a Docker pull, let's say MySQL. So MySQL is one of the images. The repository name for MySQL image is very, very simple because it's an official image. So I'll say docker pull MySQL and without specifying a version, and you can see that this is pulling down the latest version. If you don't specify a colon tag, what happens? It would pull the latest tag. However, you have to remember the fact that the latest tag might not really be the latest. So go to the repository, check the tags and check which release the latest tag is attached with, and then make sure that you are really using the latest release. Now, if I do a Docker images after the pull of MySQL is completed, you'd see that MySQL is also listed in here. Now, one of the important things that you need to know about the pull command is the pull command just downloads the image from the registry to your local. It does not run it. If you want to run it, you need to use docker run. Docker run checks if it's available in the local. If it's not available in the local, then it pulls it and creates a container. So until now we discussed the fact that a single image can have multiple tags, the latest tag might not actually be the latest, and that pull can be used to pull an image from the registry to your local. The other thing we talked about is the fact that MySQL is a official image. Now, what is an official image? Let's do a docker search MySQL. I would want to search for any image which contains MySQL. Let's do that. So if you don't know if there's a specific image that exists with that specific name, you can do a search. So docker search MySQL. You can see that over here, the first one which is listed is MySQL and it says official OK. So this is something which is Docker official. You can see that there are a lot of Docker official images and there are a lot of things which are not official as well. So what is an official image? Basically, Docker official images are a curated set of Docker repositories. Basically, Docker has a team which looks at these images, make sure that they are meeting certain standards, and they publish all this content in the official images. So whenever you'd want to use an image for some software, let's say you'd want to use a MySQL image, or let's say you'd want to use a Tomcat image, or you'd want to use a Java image, make sure that you're using an official image. Let's look at a few more commands related to images. You can do docker image history and look at the history of an image. Let's say I want to look at the history of this specific image. I'm using the image ID. You can also use the repository name :tag. What you're seeing in here is the steps involved in creating that specific image. You'd see that in certain steps, there is a file size attached. So there is a layer added in with about 5 MB. And after that, there are a number of instructions which were run to create that image. And after that, there is another layer added in with 99.3 MB. This is the largest layer in here. And this one is typically the layer where we add in Java. So the JDK which is added in is about 99 MB. And after that, there are a couple more instructions which are run. You can see that we are exposing port 5000 on that specific image. And you can see that a file is added in. Typically, when we are talking about Spring Boot application, that's a jar file. So you can see that that size is about 38 MB. And there were a few Java options which were set. And a command is set to run something when a container is created from this. We will look at all these commands a little later. Entry point, env, add, expose, volume. We'll talk about all these commands a little later. But the important thing for you to understand is when you do a Docker image history and provide an ID of the image or the repository name :tag, you would get all the history, all the steps that were involved in creating that specific image. You can also do something called Docker image inspect and use the ID of the image. When I do the inspect, you can see that I can see the tags. You can see that this specific thing has 2 tags. We just added a tag called latest on this thing. You can see the digest. You can see when it was created. You can see the containers which were created from it, some configuration related to that. You can see the entry point, which is basically the command which would be run when you create a container out of this image and launch it. You can see that it's running some complex version of java-jar/app.jar. So it's launching up the app.jar as java-jar. You can see the Docker version which was used to create it. You can see the exposed ports. You can see that this is actually running on 5000. You can see all the environment variables which were set: path, Java home, Java version, Java Alpine version, and all that stuff. And you can see a lot of information about the folder structure, the different layers which are present, and all that stuff. Some of this might not really make sense to you for now, but for now, remember the fact that there are two important commands, docker image history and docker image inspect. You can also remove an image from the local. So I can say image remove. The important thing is this will only remove the image from your local machine. It will not really delete it from the Docker registry. So if I do a Docker image remove, and let's say I specify the image ID for MySQL, what happens? You'd see that the image would be removed from our local. So if I say Docker images, you'd see that there are only 3 images which are present in here. In this step, we looked at a lot of commands related to Docker images. We saw how we can tag an image. We saw the fact that a single image can have multiple tags. We saw that we can search for an image by using Docker search. We saw that there are a few images which are called official images. Typically, things like Java, MySQL, and a lot of standard software have official versions. It is always recommended to use official versions when you can. We also looked at commands like Docker image history, Docker image inspect, and we also were able to remove an image from our local by using Docker image remove. I hope you are having a wonderful time, and I'll see you in the next step. Until then, bye-bye. Welcome back. In the previous step, we explored a number of commands related to images. In this step, let's explore a number of commands related to containers. Earlier, we created a container by using docker run -p 5000:5000 and the repository name followed by the tag. The interesting thing is the fact that this is actually a shortcut for a command actually called docker container run. So typically what you would be using is docker run, but the thing you need to understand is actually what you are running is a container. So we are creating a container from this specific image. So you would see that this would actually launch up a Docker container. I'll use -d to launch it up in a detached mode. So you'd get the ID of the container. One of the interesting things is you can pause and unpause a container. So you can say Docker container pause and give it the unique identifier. It can be a entire ID, or I can use a part of the ID, the starting 4 digits of the ID, and pressing enter. You can see that now this container would be paused. So if I try to do docker logs -f, so I'm following the logs of this specific container 6478, you'd see that the application is started up, but when I try to access the URL, I'll not get a response back because this is in a pause state. How can I unpause it? I'll do a Control-C, and now I would say docker container unpause 6478, and you'd see now that you would get a response back. So pause just stops the container in that specific state. We already explored the stop command, docker container stop. It would stop a running container. You can also inspect a container. So I can say docker container inspect. This is very similar to the command that we ran on the image. So I'll say 6478 again. When you do a docker container inspect, you can see tons of details about that specific container, the image it is created from, a lot of metadata about the container itself, when it was created, what is the current status. You can see what's the platform, the details about the image, the port bindings, the volumes, a lot of stuff you'd be able to see in here. Whenever you are expecting something to happen with a container and it's not happening, probably this is the place you can look at. This would give you tons of data which you can look at and see what's going wrong. The other interesting command related to the containers is docker container prune. Before that, let's do a docker container ls-a. You can see that we have one image in a running status up 3 minutes, and most of the other images are in a exited status. And let's do a docker container prune. This would remove all the stopped containers. So yes, I would want to remove all the stopped containers. And let's now do a docker container ls-a. You can see that except for the running container, all the other containers are removed. So if you want to clear out all the containers which ran, docker container prune. Earlier, we looked at the stop command. What does the stop command do? We saw that the stop command gracefully shuts down the container. What do I mean by a graceful shutdown? Let's see that in action. If I do a docker container ls right now, you would see that I have one container running. I want to tail the logs for it. So I'll say Docker container logs -f to tail the logs. So I would want to keep following the logs which are coming out of it. And I'm entering the first 3 digits of the ID from here. So let's press it. So now we are able to tail the logs. I'll open up a new terminal. So I'm opening up a new terminal. And what I would do is Docker container ls, and I'll send Docker container stop 1b1. Let's see what would happen over here. You can see that at the end, after the starting of the application, there is something called shutting down executor service. So it's shutting down the executor service, it's closing the entity manager factory, and then it's dropping the table sequences, and it's shutting down the connection pool. So you can see that after I called stop on the container was given some time to finish its processes to shut down gracefully. So things like closing out the connection pool, things like shutting down the executor service, the container was given time to do all that stuff. In technical terms, when I do a container stop, the signal which is sent to the container is something called sig term. It means take about 10 seconds and make sure that you gracefully complete your execution. What I'll do is I'll do a clear and I'll start up another instance. Again, I'm using a detached mode. So I'm starting another instance of that container again. Let's go back. And now over here, I would say Docker container kill. The ID would be a little different, right? What's the ID? 9b8. Before I kill, I would actually want to check the status. So I'll say Docker logs -f 9b8. So we are following the logs. The application has started up. Let's kill it right now. Let's see what happened. The container was stopped as it is. It was not really given time to do anything. It stopped dead. In technical terms, what happens is in here, a signal called sig kill is sent out to the container and it immediately stops. The command which you should use most of the times, actually 99.99% of the times, is Docker container stop. You'd want to give your container time to shut down gracefully. Now, before we get to the next command, let's actually run Docker container prune. Before Docker container prune, make sure that you don't have any containers running. So I've stopped all the running containers and I'm doing a Docker container prune to remove all the stopped containers. I'll do yes. So we have no containers running right now. So if I do a Docker container ls-a, there are no containers down here at all. Now, what we want to do is we would want to start up our earlier application. We want to do a Docker run -p 5000 in a detached mode. Right now, we would want to add a restart policy of always. So what we are doing is we are adding --restart is equal to always. This is called a restart policy. Two of the most popular values for a restart policy are always and no. The default is no. What we are specifying right now is always. If you specify always and start this up, so I'm specifying always and starting this up, I'll do a Docker container stop 501. What I'll do over here is I'll restart the Docker desktop. Before doing a restart, let's actually list the containers which are present in here. So ls-a, you can see that this has exited out. But we have created this actually with a restart of always. So what would always do? What always does is when you restart your Docker desktop, I'm doing a restart of my Docker desktop, you'd be given a warning. That's okay. Let's go ahead and restart. You can monitor the status in here. It's being stopped right now. It's now saying it's starting up. Wait until the status shows started. Okay, cool. Now it says Docker desktop is running. That's cool. And now I'm doing a Docker container ls. What's happening? You can see that the status of this container is now in running. What happened? this container is automatically started. Because we specified a -- restart is equal to always, whenever you restart your Docker and the Docker daemon restarts, it sees if there are any container with the restart policy of always. If there are any, it would launch them up. The only way you can actually prevent the restart from happening is to first stop this up. So Docker container stop 501, give it some time to gracefully shut down, and do a Docker container prune. This would remove all the stopped containers. So if you do a Docker container ls right now, nothing is present. So now we have deleted that container completely. So there is nothing present right now with a restart of always. So the restart policy also is very, very useful, especially if you have things like databases which you would want to keep them always running. You can set a restart policy of always, and even if the Docker daemon restarts by accident, at the startup of the Docker daemon, that specific container would be always launched up. In this step, we looked at a number of commands related to containers. We looked at pause, unpause, inspect. We looked at prune. We looked at the difference between stop versus kill, and we looked at what is a restart policy. I hope you are having a wonderful time. There are just a few more things you would need to know before we would start actually exploring the world of creating Docker images. We would want to actually create Docker images for our REST API, for our web applications, for full stack applications and microservices. We will get there in a couple of steps. I'll see you in the next step. Until then, bye-bye. Welcome back. In the last step, before we start actually looking at the applications and building images for them, let's look at a few more interesting Docker commands. The first command we will be looking at is Docker events. What I'll do is I'll go to the second tab which is present in here. I'll do a clear and run Docker events. Initially, I'm not seeing much action happening. So I'll do a Docker container ls to see what containers are running right now. I have one container up and running, so let's stop it. So Docker container stop C710. Now, if you go to the next tab where we have Docker events, you can see that a lot of events are happening. The Docker events helps us to see what events are happening with Docker. You can see that this container is now being stopped. You can see that this container has disconnected from the network. You can see that this volume is unmounted. We'll talk about volumes a little later. Now, let's try and launch up another container. So I'll launch up the same image that we used earlier, -p 5000 5000 -d in a detached mode, and let's launch it up. And over here, let's go to the events, and you can see that there are a lot more events which are happening. So if you want to see what's happening with your Docker environment, what is it doing, you can do Docker events and you can see what's happening in the background. It keeps running continuously. Now I'll do a Control-C to terminate the Docker events and do a clear. The other interesting command is Docker top. What does it do? The Docker top actually is used to check what is the top process which is running in a specific container. Let's do a Docker container ls, and this is the container ID which is running right now. So I can say Docker top and give the ID of the container. And you can see all the processes which are running in that specific container. You can see that there is just one process running in that container, and the process is the running of a jar. So java-jar/app.jar. The other interesting command is Docker stats. So Docker space stats, and this would show all the stats regarding the containers which are running. So right now we have one container which is running, and you can see what its name is, how much amount of CPU is it making use of, how much memory is it making use of. It is making use of about 320 MB. It has a limit of about 2 GB of memory, and you can see that it has a memory percentage. So it's using about 16% of the memory which is allocated to it, 320 out of 1.95. You can do the math. So you can see all the metrics, stats around your running containers. Now I would want to run another container from the same image. However, this one I would want to run it on port 5001, and for this one I would want to add in specific memory and CPU limits. How can I assign that? I can tell over here saying -m 512M. So what I'm saying is this specific container can only use at a maximum 512 meg of memory, 512 megabytes of memory. You can also use something like 1 gig, or you can say 0.5 gig. So let's change it to 512M. And you can also assign a CPU quota. So you can say -- CPU quota. And you can put in a value in here. Typically, the entire quota which is present is 100,000. So out of 100,000, which is 100%, how much CPU quota do you want to allocate to this specific container? I'll say around 5,000. So we are assigning 5% of the CPU to this specific container. That's a very less thing. So let's see what would happen. It tries to launch that container up. And over here, you can see that over here, this container is using about 5%. So this is where we are running our Docker events, actually Docker stats. And you can also see that the limit is now set to just 512 MB. And because it's using just 5%, it would be very, very, very slow in starting up. If I do a Docker container logs and say 3FB, actually, I should have said -F3FBs, you can see that it's hardly doing anything at all. So what I'll do is I'll give it a little bit more CPU. So I'll say Docker container stop 3FB. Even the stop is taking a long time because we have not given it enough CPU, right? Even to do the stop, it needs to gracefully shut down, right? So let's do a run and let's give a CPU quota this time of a little bit more. So let's actually make it 50,000. So we are giving it half the CPU. And let's run this right now. And you'd see that right now it's using about 50%. That's half. And you can see down here that the amount of memory increase is much, much higher. So it's starting up faster. And now if I actually do a Docker container logs -F on this particular one, 57F, right? So sorry, it's 57F. You can see that there are certain things that are happening. So not as fast as earlier because we are only assigning half the CPU, but you'd see that it's going fast enough. Let's close that, Control C, and what we are interested in is in the next command, which is called Docker system df. What does it help us with? It helps us to look at all the different things that your Docker daemon manages. So Docker daemon manages your images, your containers. We'll talk about something called volumes a little later. You can see all the details around that. You can see that there are 2 images which are downloaded. You can see that one of them is active. You can see what's the size of them in total. You can see what are the containers which are present, how many of them are active, how much size are they making use of, and you can see all the local volumes. Cool. In this step, we looked at a few more commands. We looked at Docker events, which is used to monitor the events which are happening with your Docker engine or the Docker daemon. We looked at Docker top, which helps us to see all the processes which are running in a specific container. We looked at Docker stats, which gives us the stats for each of the containers which is running. How much memory is it making use of? How much CPU is making use of? And all that stuff. We also looked at Docker system df, which helps us to look at what are the resources that are being managed by our Docker daemon and how much size each one of them have. And we also looked at how you can set memory and CPU limits for your containers. Until now, we have been playing with images which are already created. How about starting to create images? That's what we would be doing in the next section. We would start creating images for a number of projects. If you are excited to do that, I'll see you in the next step. Until then, bye-bye. Welcome back. Welcome to this new section where we would start creating images, Docker images for a number of Spring Boot projects. We have a number of projects lined up for you: a REST API, to-do web application, a to-do web application connecting to MySQL database. We have a full stack application with Spring Boot and React, and we have a number of microservices inside the microservices folder as well. What we would do during this course, we would actually play with all these projects, understand them, and then create Docker images for them and run them as part of Docker containers. And to be able to do that, we need to download them. How do we download them? Either you can do a git clone and clone this specific git repository, or you can download the zip. So you can click download zip. Once you download the zip, what I would recommend you to do is to extract the zip to some folder on your local machine. What I've done is I've exploded it out to a folder called Docker Crash Course Master, which is present down here. So all the content from the zip file is now present in this specific folder. Now you can start up Eclipse and choose a workspace anywhere on your hard disk and say launch. Make sure that you are using one of the latest versions of Eclipse. You can close on the welcome window and you can do a file, import existing Maven projects. So file, import existing Maven projects, and next. You can choose the folder where you have extracted the zip file to. I've extracted it to in 28 minutes git Docker Crash Course Master. So that's where it's present. And over here, you'd see that there are a number of projects which are present in here. Let's deselect all. And to start off, what we'll do is we'll import projects 1, which is Hello World REST API. We'll import project 2, which is To-Do Web Application H2. We'll import project 3, which is To-Do Web Application MySQL. We'll import project 4, which is the full stack. And we'll import the microservices projects alone. So we'll import from 05, we'll import the currency exchange service, and we'll import currency conversion service. So out of the projects which are present there, we are choosing the first 6 projects, 01 to 04, and inside 05 microservices, there will be multiple projects, out of which we are choosing just the currency conversion service and the currency exchange service, and do a finish. If this is the first time you are actually importing these specific versions of Spring Boot, this import would take a long time, because this would need to import all the dependencies for 6 different projects. And all these are almost real world kind of projects. So they have a lot of dependencies which are used in there. So you would see that it might take a lot of time. Now, if you have any problems with the import, what you can do is you can refer to the troubleshooting instructions, as well as you can look at this specific playlist. So among the installing guides, installing Java, Eclipse, and Embedded Maven, if you open this up, these are a set of 4 videos inside a single playlist. And the 4th video in here would help you with troubleshooting any problems that you have. So you can either play that video, or you can actually use this troubleshooting guide which is present in here. So this should help you to solve any problems that you would face with importing them in. Typically, you should not really face a lot of problems, and at the end you would see that everything is imported in properly. I'm sure you are excited to run these applications and create Docker images for them. I'll see you in the next step. Until then, bye-bye.